Hello students, today we are going to discuss solving linear equations and inequalities. This should be a review from Algebra 1. Remember, when solving linear equations, you're going to use the order of operations in reverse. Now let's look at some examples. For example 1, we have x divided by 3 minus 2 is equal to 5 minus 1. Like I said, we're going to use the order of operations in reverse, so we're going to start with adding and subtracting. So let's go ahead and simplify this right side of the equation. So we're going to simplify that to 5 minus 1, which is 4. And then we have x divided by 3 minus 2. Next thing we're going to do is add 2 to both sides. So we're going to get 6 for the right side of the equation, and we're going to get x divided by 3. Now we need to get rid of that divided by 3, so we're going to multiply both sides by 3 in order for the 3's to cancel. So you're left with x is equal to 6 times 3, which is 18. In example 2, we are still solving a linear equation. For this one, I need to combine like terms, so I need to combine the 6y and the 3y. When I'm solving equations, I like to move over the term that will give me a positive number, so I don't have to deal with negatives. So in this case, I'm going to move over the 6y. So I'm going to add a positive 6y to both sides, which is going to leave me with 17 is equal to 25 plus 3y. Now I'm going to move over the 25 to the other side, so I'm going to subtract 25. And I'm left with 3y is equal to negative 8. The last thing I need to do is divide both sides by 3. So my final answer is y is equal to a negative 2 2/3. Remember, when solving linear inequalities, when you multiply or divide by a negative, that causes the inequality symbol to flip. Now we are going to practice solving inequalities. For this first inequality, I'm going to solve for x, and in order to do that, I need to divide both sides by a negative 3. And remember, when we divide by a negative or multiply by a negative, the inequality changes. So now it's x is greater than or equal to negative 3. And with inequalities, we're going to go ahead and graph this on a number line. So I'm going to graph this. So negative 4, negative 3, negative 2, negative 1, and 0. And because we know that when you have less than or equal to or greater than or equal to, you have a closed dot. And numbers greater than or equal to that are going to be shaded to the right. Here's another example of solving an inequality. So first I need to use order of operations. So let's go ahead and simplify this. So I have 4x plus 11 is greater than or equal to 22. And this negative distributes, so it's negative x, and then a negative become a positive 4. So now if I simplify this, I have 4x plus 11 is greater than or equal to is greater than or equal to 22 plus 4, which is 26, minus x. So now I need to combine like terms, so I'm going to add x to both sides. So I have 5x plus 11 is greater than or equal to 26. Now I need to get the 11 to the other side, so I'm going to subtract 11 from both sides. So I have 5x is greater than or equal to 15. And the last step, I'm going to divide both sides by 5. So my final answer is x is greater than or equal to 3. Once again, since this is an inequality, we're going to go ahead and graph this on a number line. So I have 0, 1, 2, and 3. And because it's greater than or equal to, I'm going to have a closed circle at 3, and numbers greater than 3 will be shaded to the right. There are two different types of compound inequalities. The first type are AND statements, and these include all of the values within a range. The other type are OR statements, and in this case, both parts cannot be true at the same time. Now let's look at an example of an AND statement. In order to solve this, we are going to solve it just like we were inequalities, but now whatever you do to the middle part, you're going to also do to the left and the right side. So first thing I need to do is subtract 7 from all 3 places. And then simplify. 12 minus 7 is going to give me 5 is less than or equal to 5x, which is less than or equal to 32 minus 7, which gives me 25. Now I need to solve for x, so I'm going to divide everything by 5. 5 divided by 5 is 1, which is less than or equal to x, which is less than or equal to 5. So now I'm going to go ahead and graph this on a number line. And because it's less than or equal to, I'm going to go ahead and use a closed circle at 1 and a closed circle at 5. And we said that this is an AND statement, so you shade in between 1 and 5. Our last example is an example of an OR statement. So what you're going to do is solve these both individually, and then you're going to graph it on a number line. So if I solve the first part, I'm going to subtract 2 from both sides. So I have x is less than or equal to -3, or I'm going to solve the part on the right, so I'm going to add 2 to both sides. So x is greater than or equal to 3. So now I'm going to go ahead and graph this on my number line. So I have -3, -2, -1, 0, 1, 2, and 3. And because it's greater than or equal to and less than or equal to, I'm going to use the closed circle. So I'm going to use a closed circle at -3 and a closed circle at 3. And I'm going to shade accordingly. So I need values less than -3, so I'm going to shade to the left. And then I need values greater than 3, so I'm going to shade to the right. All right, if you have any questions, we will go over those tomorrow in class. Have a great evening.